Hi, I'm Pat Wallace, the Facilities and Workplaces Practice Lead at Esri. Thanks for inviting me to speak today about how GIS is integrating our digital and physical worlds and how I believe Esri can help. First, a little bit of background on who Esri is. We're the global leader in Geographic Information Systems, or GIS, as well as location intelligence and mapping. GIS is a system that connects users engaged in a business process to location-based information products that serve the needs of those processes. Our customers range from your local city and county mapping property information to electric utilities, managing the expansion of pipes and wires, to identifying where they need to fix power lines and outage, to the U.S. government, like the Census Department, DoD, FEMA, EPA, managing public lands, and relief organizations to understand where to deliver needed medicines and foods around the world, as well as manufacturers to manage dealer networks and optimize their supply chains, to drive growth, optimize their operations, and increase business resiliency. Every year, our software is used by almost all the Fortune 100 and 500 companies, almost like all states, all 15 executive agencies, almost every independent U.S. agency, almost all the top 100 colleges, and we spend 30% of our revenue directly on R&D. I want to talk a little bit about that facilities and workplaces practice I mentioned. Our customers, we find that they want the guidance, know-how, and vision to innovate and drive data-driven change and the ability to turn on smart building, campus, and workplace capabilities. We do it by applying our deep experience in ArcGIS, business and digital transformation, as well as subject matter expertise and business operations affected by and shaped by the built environment. The result merges digital and physical environments to drive positive outcomes through dynamic engagement, provides greater insight through the contextualization of this information. This is the marriage of location and business intent to increase operational efficiency and effectiveness. So we wind up getting involved in a wide variety of work, from portfolio management to FM, to facilities planning, venue management, site security, environmental health safety use cases, you name it. But facilities divisions, if you aren't aware, are weird animals, like chimeras, a mix of disparate business lines whose nexus is the physical infrastructure of a business, its sites, facilities, and structures. This snapshot is a typical structure for a large facilities division at any organization. Here you can view the missions for each business line as more tactical on the left to more strategic on the right. And there's often interplay between the various business lines. For example, the planning group may scope activities for working with the maintenance branch to programmatically assess facility conditions. The results are then used to establish inspection schedules and out-year maintenance budgets. Sometimes proposed repair costs exceed the value to replace, so the planning group kicks things over to the A&E group and program group to draft design build specifications, and then work with the real estate branch to acquire and justify the capital funds for the new building. Now, traditionally, and even still today, those managing and using the built environment are faced with a myriad of endemic challenges, like inventory control and total asset visibility, completing more projects and on time, completing the right projects, reducing operating costs, eliminating unnecessary capital expenditures, as well as data interoperability problems like corralling your AEC data sources like CAD and BIM with your operational technology, your OT with your IT business systems. And this last one affects all the former. Organizations are struggling to overcome the disconnect between their teams, their processes, their data, the things they manage. For example, making decisions requires accurate and timely data, but unstructured data is hard to analyze and slows business operations. Project-based architectural and engineering sources are not created or delivered in a way that meshes with how your business operates. These data costs can approach 34 cents per square foot annually for required data assembly and conversion. Plus, you're challenged with synthesizing disparate third-party business systems across stovepipe business lines. And then you have to try and synthesize in real time your OT sources, like your SCADA and building automation and sensor data, with your IT. This disconnect has a real cost that quickly adds up. Now, facilities has been at the forefront of everyone's mind over the last year as organizations struggle with how they get back to the office. And every day, the people managing those changes are required to deliver authoritative floor plan data to executive decision makers and project stakeholders and the employees they impact. The speed with which these decisions need to be made and the requirements to share these data in a timely and coordinated manner has only accelerated. This talk of decision making assumes, of course, your organization has invested in decision support capabilities. Now, what I mean here is that business processes and digital infrastructure have been coordinated to foster, manage, and support both decision making and action taking. Decision management is a science, and it's not something that just happens. The role of decision support is to provide a structure to thinking and rationality to subsequent actions. So understanding your operating environment, which is at the left here of this diagram, the observation, the structure of the problem, is equivalent to understanding how operators can act within it to realize their objectives. So in essence, the operating environment is quite literally many times a map of possible decision making and action taking. And the diagram in front of you, it depicts the OODA loop, where from left to right, we start with observation, understanding the nature of the problem. To orient, this is where the decision maker orients themselves to the problem. And the vector that surfaces shows alternatives to solving the problem. Decision, self-explanatory. Action, this is not where the story ends, but where it begins. And there should be a continuous feedback loop affecting how we observe the operating environment, the choices we have in subsequent decision making. The purpose being to increase decision throughput and to ensure greater success for operators in the field once decisions are made. GIS is a type of decision support system that has been used successfully this way for the last 50 years. In particular, over the last few years, GIS has extended its gaze beyond the natural environment and has rapidly moved into buildings, campuses, and cities so that those charged with managing the built environment have the right tools to visualize, analyze, share the insight needed to make better, faster decisions and to ensure the success of actions undertaken based on those same decisions. You'll see here use cases spanning all types of facilities, including defense, utilities, transportation, public housing, and more. These are real-world examples, and this is happening around the world today. At Esri, we strive to provide a framework for location by developing tools that provide the baseline for decision-making and action-taking. So unlike a traditional facility management system, our GIS platform is designed to consume and integrate a variety of different data sources and provides a framework to integrate, visualize, analyze, and share data for a wide variety of use cases. Based on a wide variety of data sources like project-based AEC data, BIM and CAD, as well as location data and real-time data sources. But no map or connected data environment is useful without business data and the ability to transact against it with systems like your ERP or CMMS or IWIM systems. And second, GIS now provides one map that can be shared across your organization. Over half our customers don't have a system of record for their facilities. By showing all their facilities and floor plans on a map, we can provide a corporate asset that can be used again and again across their enterprise. This business geography is a new type of system of record. Together, this business geography provides the common operation picture required to understand the nature of the problems confronting you and how you can potentially orient your organization to solve those problems, as well as to respond to them appropriately. It contextualizes location and business intent to improve decision-making and operator efficiency. So because of that, you no longer have to have stakeholders send numerous emails interdepartmentally and interorganizationally and wait multiple days in order to get access to facilities information again. All of the data you are collecting about your facilities are organized in 2D and 3D indoor maps that let you easily discover and share data with all who need it. Authoritative maps are accessible from your desk, in workshops, on the go using our native mobile and iOS and Android applications, and even in kiosks that are deployed throughout your workplace. This provides new patterns for interaction, like office hoteling and meeting room reservations is one example. These capabilities also lead to the ability to complete more projects with facility maps that are organized into GIS, with assets and points of interest mapped and made visual, and the ability to produce hundreds of unique maps for departments, teams, and unique users with maps that recognize role-based user identities and can be configured to honor a variety of authentication methods. Stakeholders are now not wondering, where will this data go once I share it? Who will have access to it? Who should I check with on another team before I share it? ArcGIS users can respond to requests for data and services faster. They can collaborate better and focus on finishing their tasks. We actually had a customer where the facilities department was measured on how many work orders they resolved. ArcGIS provided an easy way for occupants to report issues, so they received many more requests, which highlighted the need for better facility maintenance. So this organization was able to show they were resolving more work orders faster and making their workplace better and safer. And that leads us to really improving the bottom line. Facilities and workplace operations teams dream of shrinking their maintenance backlogs and tasks and reducing costly space fragmentation. Now, with easier access to facilities data and faster collaboration among project stakeholders, these dreams are even closer to reality. With the right tools given to data managers needing to prioritize planning and allocation of resources, organizations can make strategic decisions to defer maintenance or right-size their footprint and save costs. The entire organization can flourish. Employees and visitors on the left, operation managers and field operators on the right can all benefit from a wide spectrum of ArcGIS Indoors capabilities. Employees and visitors benefit from improvements to their workplace experience and safety, whereas managers and operators can leverage the same applications configured differently and with different maps to improve industrial safety and create efficiencies in existing workflows to increase throughput. I want you to pause here for a second and look at this. This is real ROI from a real customer. Over 20 buildings, 5 million plus usable square feet, 185 miles of paths and corridors, 10,000 plus employees, 1,000 plus visitors daily. Now, one of Esri's geo-enabled solution systems is the ArcGIS Indoors product. Indoors provides a web and mobile building occupant experience. It supports facility operations. It includes an out-of-the-box app for space management. It supports site security and provides data management tools to build floor-aware maps from project-based engineering data sources. In addition, it offers device tracking to support finding and tracking people across the workplace, whether they're indoors or outdoors. Now, to do any of this, you have to have a connected data environment, which ArcGIS provides. It's configured and deployed to provide software representations of your physical asset systems and business processes, and is designed to detect, prevent, predict, optimize through real-time analytics to deliver business value. Now, one framework with which we can understand this is through the lens of a digital twin. So let's look at the maturity level of digital twins. So at level 1, you can think about reality capture content and other 2D and 3D visualizations like CAD and BIM and even other GIS data sources. And at level 2, we've contextualized the level 1 data in the real world, right? Connected it to each other. Leverage the hierarchy of the building structure that, we referred to in our business geography. At level 2, we connect that data that's been contextualized in absolute space to other business data, right? Other metadata about your buildings and spaces and assets in your business systems. It could even be in a spreadsheet. As long as there's a common key, we can connect to it. And then building on that, we can start funneling in real-time data, through that framework, right? We've contextualized all the level 1 data in the real world. We further contextualize business data with that data, and now we can funnel in real-time data through that framework to provide immediate insight and value to your organization. And then on top of that, we can, store that data, look at analytics, kind of like A/B testing to compare how we're doing now to yesterday, to a week ago, to last quarter, to last year, look at it seasonally, look at it compared to other things in the same organization. And level 4 is this idea of two-way communication and be able to affect the physical from the virtual, right? So if after I've looked at things in the virtual at level 3 and looked at various simulations to get the best outcome, we can lock that logic in and deploy it in the real world, right? To affect real world change. And then use that learning and bring that back into the model. And then, after gaining that capability, we can go to level 5 where it's autonomous, self-healing, self-correcting. And so if we go back and we look at our connected data environment broken up into those categories, we can see the level 1 content on the left, the idea of the spatial content at level 1, the other metadata that we can connect to it at level 2, and then building on that, being able to bring in the real-time and sensitive data through those other two levels of data. And then level 4 and level 5, of course, build upon the other 3 levels. And, here's a representation of just kind of understanding what you need to do to provide value for decision support through digital twin capabilities, right? So on the x-axis, we are looking at the digital infrastructure needed to build a digital twin, right? And on the y-axis, we're looking at your decision throughput. And on the z, we're looking at the business process effort, like the actual work it takes to get something done. So, let's say the purple line is like probably the default state, right? Like not a lot of digital infrastructure. And, therefore the decision throughput's limited. And the process effort is high, right? It's all very manual. And then getting down to like this magenta colored line, we can see like we've implemented the digital infrastructure necessary to build a digital twin. Therefore, I can increase the decision throughput rapidly, right? And the process effort is low because a lot of it is automated. And so let's take a look at this in action, right? So here, ArcGIS, you can think of it as that single pane of glass used to gaze into the other business systems and sensor networks you've deployed. So by ingesting your engineering drawings and creating 2D and 3D models reference to the rest of the world, you can begin to snap other location data sources together with it, like typical GIS sources, like aerial and LiDAR data. And you can include other engineered civil drawings that GIS, we can natively read in our GIS. And we fuse all that foundational location data to your critical business data. And this includes leveraging our real-time technologies to perform a space-time join on data coming in from the field, as well as on, the IoT, SCADA, and remote sensing sources. We can then archive these operator actions and sensor telemetry and use our analytics engines to mine those data stores for additional insight. This is the insight used to truly understand the nature of the problem, to formulate the best course of action, and provide rapid feedback between operators in the field and decision makers regardless of where they are. But customers don't start with everything. They start at the start, right? So we think of that as starting with their initial operating capabilities, right? Laying in the foundations, creating the compute environment, hydrating the system with the initial, level 1 type of data sources. And then, at the next step, you get to the level 2, you begin connecting it to, all this other contextual data, other contextual business data, like your business systems. You can even start bringing in real-time data from your building automation and SCADA systems and other sensor systems. And then you can start building other advanced capabilities on top of that. But you have to start at the start. So now I'm going to dive into a section where we talk about the interoperability and extensibility of this platform. And I'm going to start talking about, integrating engineering and architectural data sources. Now, in terms of CAD, one of the biggest challenges you'll find is with project-based data like CAD or BIM. So in terms of CAD, it represents the as-built condition, which fails to represent current conditions. CAD does not have an underlying database driving symbology and annotation, or supporting feature relationships to query and analyze. A result is it fails to support a multi-user editing environment necessary to keep the drawings current. Instead, it's just updated when major renovation or new build projects are completed. Further, the way the drawings are stored by project means organizations absorb costs organizing these data and disseminating them in a timely manner to make them useful for daily operations. The reality is it can take days, weeks, or months before a productive view is delivered. Data entry is typically needed, and consolidation of disparate project views into a single source of truth is a prerequisite. And this can cost up to 34 cents per square foot annually, and that's in 2021 dollars. ArcGIS is built to solve this problem. We can visualize 2D floor plans in the context of the real-world location and operational data layers from other relevant business systems. By translating the drawings of many floors across many buildings into a single geodatabase from your CAD and BIM, we can use attribute-driven symbology and spatial analytics to generate derivative information products for use across the web and other mobile applications. With up-to-date, persona-driven views of building information, organizations can now engage their knowledge workers and other stakeholders in operations, in maintenance, management, and other planning processes. Now, today, ArcGIS Pro has the capability to read the contents of an Autodesk Revit design file, and we continue to enhance those capabilities. Since 2018, when we first implemented Revit as a data source and ArcGIS Pro 2.2, and in 2021, we're at Pro 2.8 and continuing to build in more advanced capabilities. In ArcGIS Pro, we can make a BIM cloud connection to BIM 360 using my Autodesk named user. And here we can browse BIM 360 project folders to add civil and BIM content to my map. And I can check the status for the most recent version of my design files and refresh them. I automatically retained and persisted a link back to the source documents and project folder. The link remains with the feature and can be activated in desktop or web applications like a simple combination to provide the GIS user the ability to link to source information in various views and gain access to design content where it lives. And we can expand content management to include design files stored in Autodesk BIM 360. So GIS users are provided an in-desk view of data stored in BIM 360. They can download design files for direct use in Pro. That includes their Revit and drawing files and other PRG support files. And it maintains references to the source. And we can get the latest for updated files. Right, so, and here's an example of looking at the Esri partner card directly in BIM 360. So it's not just a one-way street, right? So here directly in BIM 360, we can look at the Esri partner card. And then diving further, we can take a look at the fact that this is a real scene, right? So this interacts directly with the ArcGIS system. Now, a very important addition at ArcGIS Pro 2.6, and we've iterated on for the last few releases, includes the support of reading the more structured AEC entities from Autodesk Civil 3D files. This means that AEC entity information inside of DWG files created from Civil 3D can now be read directly in ArcGIS Pro. So this includes alignments with linear referencing information. Attributed survey points and pipe networks are now accessible by ArcGIS Pro to fuel your GIS applications and maps. So we can support Autodesk Civil 3D AEC entities in Pro. We have expanded DWG support for 38 civil entity types like pipes, parcels, roads, center lines, curb lines, and surfaces. And new data sources for internal and external customers, like parcel fabrics, roads and highways, utility networks. And we can use this to build GIS data. So going from Civil 3D parcel to GIS parcel fabric, for example. So here you can see the advancement of support of Revit from 2015 to 2020. We continue to improve the usability of Autodesk Revit with files as a source of GIS features. And, you can see in 2.6, we introduced building layer management, 2.5D objects as assets from Revit, including floor plans, site mapping, including footprints, building objects, also points of interest, all of which are used in the ArcGIS indoor system. At Pro 2.7, we had additional performance improvements in Revit 2021 support. And for Bentley DGN, we've been able to directly read DGN files for, coming on 2 decades now. And so you just load it directly inside of ArcGIS and begin interacting directly with it. Now, a growing use of CAD and BIM in ArcGIS is for indoor GIS use cases that support facility operations and maintenance. In order to use building information from CAD or BIM formats in indoor GIS, we need to convert the data into GIS features in an indoor database, which came in 2.8, a lighter weight indoor data set that supports floor awareness. This workflow consists of evaluating your data source, preparing the ETL, and using geoprocessing tools in ArcGIS Indoors for ArcGIS Pro to automate the conversion from CAD or BIM directly to the Indoors model, right? And when we evaluate CAD, we're looking for the fundamental features we want, like doors, walls, rooms, and other details that help us interpret the layout of the space. We're also checking to make sure that polylines that would make up polygon features are closed and represent defined areas. We want to make sure the base point for annotations that describe floor plan features fall within the area of the polygon that they represent. And we also want to check for consistency in layer naming and annotations to help us map the necessary features from CAD to GIS. Currently, you can use the Make Building Layer tool that I mentioned earlier in combination with the data interoperability extension's capability to read IFC data. We also look to support IFC in a similar way to how we currently support Autodesk Revit data, reading it directly as a building layer in Pro. Now, in terms of web-based integration with Autodesk BIM 360, we can now link ArcGIS with BIM content. And so this enables this horizontal and vertical location intelligence for AEC firms and those managing the built environment. So we can link directly between data sets on different project types and scales. So this enables design coordination. It improves experience of projects across time, and it helps better understand project performance. So this is great for project delivery for our AEC partners and those involved in the design and construction of facilities, right? As well as for operating the facilities once they're commissioned. Now here's an example of one of our customers, The Ohio State University, with bringing 90 plus Revit models into a single building scene layer. So you can see the performance, of this particular scene layer, right? We can look at environmental controls, adjust daylight, time of year. We can start looking at construction phases. We can see the different disciplines and begin filtering between the different disciplines in the view. And we can even go into the floor viewer and select a particular floor to look at. So very powerful capabilities that you can access today. Another area that I'd like to talk about at this kind of level 1 of the digital twin is reality capture, right? Being able to document the historical record used for quality control and monitoring during construction as well as during operations. And so here's an example of scan data being used from drones, assembled using our site scan product. And then pulled together as a mesh. right? So being able to create a point cloud and mesh data from drone or other aerial capture methods. Now I want to talk about interoperability and extensibility with regard to business operations data. And so here, location is the common key that connects your spatial data, like what we just talked about, to your business information. So with maps, either indoor or outdoor, as the foundation, we can integrate with a wide variety of third-party business systems and sensor networks. This provides our customers new insights and applications that augment and enhance these systems, and provides a way to visualize lifecycle management and business operations. Typical systems that our customers want to connect to include those listed here, like asset management, integrated workplace management systems, and maintenance management systems, and others like work orders, sustainment management, facility scheduling, security systems like badging and monitoring security incidents, as well as real-time tracking of resources, to name a few. But we have standard approaches to do this, right? We use extract, transform, and load, ETL, or direct connect of one enterprise database system directly to ArcGIS, or we can read directly in a map, right? Or read directly in a map via middleware. And so we can get into some of that in a moment. Here are examples of the systems that we can connect to, like these are integrations directly built by us or by our partners, right? That includes things like Maximo, SAP, CityWorks, ServiceNow, Tririgo, Archibus, Office 365, Cisco, OSI Soft, among others. So if we dig into the integration patterns that I mentioned previously, we could take a look at the ETL, right? So ArcGIS data interoperability includes 390 reader-writer formats, and I've actually listed them all here. So that's pretty powerful capability from moving one data type to another data type inside of ArcGIS and vice versa. Further, there's a very robust scripting environment leveraging the ArcGIS Python API. This includes ArcPy and the ArcGIS Python APIs, which are more geared towards the web environment on ArcGIS Enterprise or ArcGIS Online. So, this provides, the ability to take data from other business systems, put it into ArcGIS, and provide insight. Now, when I had mentioned the pattern of direct connect, I didn't get into a lot of detail earlier, but we literally could look at all of the primary enterprise database technologies like DB2, Informix, SQL Server, Oracle, Postgres, HANA, SQLite, etc. And all you really need is a spatial column in the source data or a common key that allows you to create a spatial view with data that already exists inside of ArcGIS. So this is very straightforward. You just literally, all you have to have are credentials to log into, those enterprise database systems, and then you can directly access that data inside of ArcGIS. When I had noted that we could directly read from a map, that seemed pretty self-explanatory, right? Esri compatible formats, of course, right? This also includes GeoEvent Server, and GeoEvent Server consumes a wide variety of information, file-based from Kafka, RSS, Socket Web, WebSocket, etc. And you can extend it with custom connectors, right? Leveraging our SDK to do that. We also include a Coop provider. I'll talk about that in a second. That's a Node.js service where we can create like a Esri feature service facade that consume data from other systems. Also standard OGC, Open Geospatial Consortium formats like the Web Map Service, Tile Service, feature services, as well as KML and I3S. The idea of reading directly into a map via middleware, that includes technologies like Coop, right? It's flexible, uses standard GeoJSON, can consume shape files, KMLs, CSVs. Examples would include the following file types that could be leveraged. So essentially, you see things like Maximo. If they have a web API, you can consume data or craft it rather into an Esri compatible format with the Coop API. And that gets us into talking about one of the direct connect capabilities, for example, is SAP. In terms of our ability to directly connect to SAP, and when we mean direct connect, it just means we can read it as another data source. It will show up in the content panel inside of ArcGIS Pro, as long as you have the right user authentication. So with SAP HANA, we read it just like an Esri database. And we can begin to bring that data directly into GIS. And this is critical as a lot of our customers, that are managing the built environment, they have their people data in SAP, or they use SAP as their ERP. And so this is where their official inventory is listed. And when we talk about Maximo integration, asset and service managers use IBM Maximo Spatial Asset Management to visualize the spatial relationships among managed assets and other map features. And Spatial extends the capabilities of the following IBM Maximo asset management applications by adding maps for assets, locations, work order tracking, and service requests. You can see here some examples of pulling in work orders directly from Maximo. And with Maximo Spatial, a record in Maximo is the same as a record in GIS. So it's very powerful for both users in GIS as well as users in Maximo. With regard for Archibus, many organizations store their floor plan layouts in Archibus, and floor plans in Archibus are already cleaned and organized. The geospatial extension for Esri provides the ability to publish levels, rooms, and equipment data enriched with detailed information from Archibus. And then users can create triggers to keep data up to date inside of ArcGIS indoors. So every time a CAD drawing is updated, it updates the self-same feature service in GIS. And you can use, these features directly in Web Central or directly in ArcGIS. With IBM Tririga, the biggest problem implementing IBM Tririga in indoors is data readiness. Users want to quickly turn on new sites and indoors and IBM Tririga indoor maps. Data currency is also key. Our customers want to know they're visualizing and using valid information and want better tools for keeping those data current. The Tririga to Indoor Spatial ETL Workbench is built to solve this particular problem set. And with it, we can visualize 2D CAD floor plans in the context of the real-world locations and enrich with operational data directly from IBM Tririga. Many organizations sync their floor plans with Tririga. And just like with Archibus, we know that floor plans synced to Tririga are already clean and well organized. And so the tool lets you seamlessly extract indoor maps enriched with IBM metadata. And it also includes the update functionality to keep ArcGIS indoor maps current with their IBM Tririga implementation. The IBM Tririga Indoor Maps is an extension for Tririga, and it unlocks a lot of visualizations for your Tririga buildings data. So you can enhance the workplace experience of users in your organization with interactive indoor maps and wayfinding. That helps organizations minimize disruptions and congestion in the office by defining safe routes and points of interest on a map. And it allows users to quickly visualize spatial data across their portfolio from their existing synchronized CAD and BIM data and scale quickly to different sites. And here's an example of one of the viewers, like for a digital kiosk, leveraging Tririga indoor maps. In this section, I want to talk to you about The interoperability and extensibility of ArcGIS to bring in real-time data from building automation, SCADA, and other sensors. So here we can leverage the ArcGIS integration pattern to create an Esri-compatible feature service via middleware. We list Siemens here as the provider for the sensor data, but in the real-time feed, it could quite literally come from any platform. And with a web API and a common key, we can connect that data from those platforms to a location on a map, like a room ID, or even latitude, longitude, and a floor number. In this example, we accomplished this through the configuration of an MQTT broker to building automation sensor that is the provider of the information to the ArcGIS GeoEvent server. ArcGIS GeoEvent is our real-time technology. It's a server that can handle huge volumes of data. And we have a SaaS version of it called Velocity that has an analytics engine built into it. And so we can use that MQTT broker to bring in that sensor data, from that provider, bring it into GeoEvent, and that GeoEvent is the subscriber of the data from these sensors through the MQTT broker. Now, MQTT is a publish-subscribe protocol that's lightweight and requires minimal footprint and bandwidth to connect to an IoT device. So, unlike HTTP, MQTT is an event-driven paradigm and enables messages to be published to clients. And this type of architecture decouples the client from each other to enable a highly scalable solution without the dependencies between data producers and data consumers. In the upper right, we see the GeoEvent interface for configuring a connector and creating a space-time join on real-time telemetry and location in a location on a map, like a room ID. In the lower right corner, we see the result in the map via GeoEvent and the MQTT middleware. Another example is OSIsoft, right? So with OSIsoft, we can pull in SCADA data directly into ArcGIS and vice versa. So by combining GIS visualizations and geoanalytics with real-time IoT data, we can provide powerful capabilities to optimize current operations and provide predictive capabilities for the future. So with the OSIsoft integration, you can create feature services in ArcGIS from data in OSIsoft, and we can use the Pi integrator to link to those ArcGIS feature services. And we can use GeoEvent Server to create connections with Pi and create real-time streams and feature layers from data coming in from your SCADA systems. So in summary, what we've described is a holistic capability of ArcGIS to better manage the built environment, quite literally blurring the line between your digital and physical worlds. At level 1, we start contextualizing all your spatial data together from your project-based sources and from your reality capture sources, and we contextualize that in its real-world location, right, as a map. And then we can contextualize business data in relation to that map. The novel thing about leveraging facilities information that it also has its inherent hierarchy of site, building, floor, space, and asset. And so this is another type of contextualization that we can use. So as you can see, we're quite literally building a meta model for marrying business intent to the physical world. And we can access it directly in a map to provide direct support to your decision support capabilities for your organization to help you better understand the operating environment that you're working within, as well as to help you better understand the options that you can take to solve that particular business problem and keep you connected with operators in the field once those decisions have been made, and provide those operators with real-time information so they can adjust fire in real time, right? Coming in from those real-time data sources. And then also providing that real-time feedback to decision makers. So to keep everybody in sync, to increase your decision throughput, and to increase the chance of success in the field once those decisions have been made. So I appreciate your time today, and I'm ready now to answer any questions that you may have. Thank you.